In part 3 of lecture 4, we will start building the scanner. Another potential problem that comes up is skipping past lead blanks and comments. Both are of no significance to a compiler. They are intended solely for the human reader. But it's not a matter of skipping past all the blanks and then the comments. They tend to be interspersed. So the only solution is to skip all the lead blanks and then the comments, and repeat this sequence until you find a non-whitespace character that is not inside a comment. This is exactly what you see in the method firstChar. We have a Boolean switch called goodChar that is initially false because we have not yet gotten a valid character with which to begin the next lexeme. First things first, if we are at the end of the file, we return the end of file marker. Then, as long as we haven't found that first valid character, we skip past all the whitespace, and if the first character afterwards is not an open brace used in the language to delimit comments, we have found it and goodChar becomes true. Otherwise, we now have a comment to skip, and then we repeat. Eventually, we will either find that first whitespace character outside a comment, or we reach the end of file. If it's the end of file, we return the end of file marker. Otherwise, we return the character. Most programming languages begin identifiers with letters exclusively, even if it means defining the underscore character as a letter. Similarly, reserved words almost always begin with a letter. Numbers always begin with a digit, at least if we treat the unary plus or minus sign before them as a separate token, which is usually a good idea. And the non-alphanumeric operators and delimiters in some languages begin with a character that is virtually always non-numeric. This makes it easy to see which of the three separate classes of lexemes we are scanning. We can use this to break down the scanner to two or more separate methods, one for words, one for numbers, and one for operators. Obviously, in a language that allows character strings, and most of them do, we would need another class for strings. We can finally write getToken, the method that will return a token to the parser. As we have done before, we will take the lookahead, and if it is the end of file marker, we will return the token end of file. If that's not the case, we now save the lookahead as C, the first character in our lexeme to be. If it's a letter, we pass the first character of the lexeme to be to scanword. If it's a number, we pass it to scannum. And if it's anything else, we pass it to scanop. In all three cases, we are receiving a pointer to the symbol table entry for the lexeme that we have just found. Additionally, the scanner returns the token for the lexeme. We still have to look at the details. A lexeme that begins with a letter can have letters and digits following that first letter. Each of the three subsidiary methods, scanword, scannum, and scanop, look up the lexeme in the symbol table. In all three cases, if we find the lexeme in the symbol table, we return its token. But when it isn't found, the methods will handle it differently. Scanword assumes that it's a new identifier. It can't be a reserved word, or it will have been installed before starting to compile the program. Scannum assumes that it's a numeric value that had not yet been found. And scanop will treat it as an illegal lexeme because the legal operators would already have been in the symbol table. In scanword, we start out by placing our first character C as the 0th character in the lexeme. And as long as our lookahead is not the end of file marker and is a letter or digit, we concatenate it to the lexeme and replace the lookahead. At this point, we need to place a null byte at the end so that we can end the string. If we were using the string class in either C++ or Java, we would not have to do this. And then comes the strangest part of this method. We unget the lookahead and then turn around and get it again. While you might think that this is unnecessary, it guarantees that our lookahead is the next valid character with which we can start a lexeme. This leaves us with the job of seeing if our lexeme is in the symbol table. The method installName will return true if it is already in the symbol table and false if it isn't. If it was not already in the symbol table, it installs it, but we still need to set some of its attributes.